Welcome back for the lesson 5.3 video. I briefly introduced right triangle trigonometry in 5.2 just because it kind of flowed natural from some of the things that we were discussing, but we're going to formally use it here. So you'll kind of find that a lot of the topics in chapter 5 all kind of definitely blend together. So if we have a right triangle, that right angle is noted here with a square. The side opposite the right angle is always called the hypotenuse. The side next to the angle of reference, so we have theta here is our angle of reference. The side next to the angle of reference is always called the adjacent side, and the side opposite the angle of reference is called the opposite side. So we have the opposite, adjacent, and hypotenuse. Now, I also mentioned this in the last lesson, but a way to remember sine, cosine, and tangent is SOH, C-A-H, TOA, SOHCAHTOA. And that sine is opposite over hypotenuse. You'll see that here, and is the ratio opposite over hypotenuse. Cosine is the adjacent over the hypotenuse, and TOA is the opposite over the adjacent, because remember that tangent is sine over cosine. So I always lay mine out when I'm writing them, because I'm going to ask you to give me all 5 or the other 5 or all 6 of the ratios sometimes in the assignments here and on the test and the quiz. So it's important that you kind of have a system to help you, and this is a system that I use, what's in this table right here. I always do sine, then cosine, and then tangent, because tangent is sine over cosine. And then I do cosecant because it's the reciprocal of sine, and then secant, which is the reciprocal of cosine, and then the cotangent, which is the reciprocal of tangent. The other piece of information that you're really going to use in this lesson is the Pythagorean theorem. And that is that a squared plus b squared equals c squared. And we're going to have to use those to solve different pieces. So the side, like I said, opposite the 90-degree right angle is always going to be called the hypotenuse, and we usually label that C. And then it doesn't matter what you call the adjacent and the hypotenuse, as long as you label them A and B, and they're both considered legs. And so I have an example here at the top of the next page. It says the 6 trigonometric functions of theta are. So if this is my angle of reference, 3 is the side opposite, and 4 is the adjacent, and 5 is the hypotenuse, because it is the side across from the right angle. And so the sine of theta is 5 over 13. And oh, I have these, my picture does not match my numbers here. This opposite over the adjacent is 3 over 4. Yours should be correct. The cosine is the adjacent over the hypotenuse, so that would be 4 over 5. The hypotenuse over the opposite is 5 over 3. The secant is the hypotenuse over the adjacent, so that would be 5 over 4. If yours is not correct, just change it to be mine. And the opposite over the adjacent is the opposite is 3 over 4. And for cotangent, it's the adjacent over the opposite, so that will be 4 over 3. Okay, let's look at an example here. Let theta be an acute angle such that the sine of theta is 0.7. So I'm going to draw this. I'm going to kind of use the same triangle over and over again. So this is theta. Sine is 0.7 or 7/10. And I'm going to write it as a ratio because I like to think of it as my opposite over my hypotenuse. So that helps me fill those in. So the side opposite my angle, is 7. My hypotenuse is 10. And that means I can solve for b. So I know that 7 squared plus b squared equals 10 squared. 49 plus b squared equals 100. And if I subtract 49 from both sides, I find out that b squared is equal to 51. So b is equal to the square root of 51. So and it's an irrational number, so we'll just have to use that. So cosine of theta is the adjacent over the opposite, or adjacent over the hypotenuse. So the adjacent over the hypotenuse, and the adjacent is the square root of 51. We can have a radical in the numerator, so that's okay. And the hypotenuse is 10. So that is my final answer. We can also use these identities here. They're called cofunction identities to help us find values that are complements of each other. So it says sine of 90 minus whatever theta is equal to the cosine of theta because they're complements of one another. And cosine of 90 minus theta is equal to sine of theta. So it says if cosine in example 2, if the cosine of 40 degrees is approximately 0.766, find the sine of 50 degrees. Well, 40 and 50 add to make 90. So that means that the sine of 50 is really the sine of 90 minus 40. And that is my theta. And so that is just equal to the cosine of that theta, or cosine of 40. And so the answer is also 0.766. So those are nice tricks to be able to use. Now we do have some special angles that are going to help us. We're going to look at geometry a little bit. One of them is a special triangle. It's the Pythagorean, or I'm sorry, it is a special triangle that where the two sides are equal to one another. We use the Pythagorean theorem, but I misspoke here. So the two sides, these two sides are equal to one another, and that's because my angles here are both 45 degrees. And so that means the angles are equal to each other and the sides are equal to each other. So that also means that the sine of 45 equals the cosine of 45, and they're both the square root of 2 over 2. Okay. Now, when we have a 30-60 triangle, those have some special rules too, because what we can do is we know that I used this rule for the 30-60-90 back in lesson 5.2. But if you have a 30-60-90, the side opposite the 30 is half of your hypotenuse. So if you say your hypotenuse is X or A, then your angle across from 30 is half of A. And your side B is the square root of 3 divided by 2 times whatever A is. So let's use some of these. So it says find the unknown angle measure and the unknown lengths of sides of the triangle below. So we have this angle is 30 and this one is 90 shown by the square. So this one must be 60. And so if that is true, then the side opposite the 30 is going to be half of, we're going to call this half of the hypotenuse. So that is 5. And then this should be 5 times the square root of 3. And so this would really say 1/2 of A and square root of 3 divided by 2 of A, whatever, whatever A is. This is all referencing side A actually up here. Okay. Letter D says determining sine and cosine using a calculator. So it says use a calculator to evaluate sine of 58 to 4 decimal places. And we have used sine, been using Desmos, but now we are using Desmos scientific calculator. Make sure you use that because it's going to let you switch here from radians to degrees. And I'm going to put it in radians. Oh, I'm going to put it in degrees. We want to find the sine of 58 degrees. So I'm just going to press the sine and then put in 58. And you can see that that is equal to 0.8480. And we know that the sine at 0 is 0. We know that the sine of 90 is 1. So you can always check to make sure, do I really have it in degrees? Because I know that 90 degrees sine is 1. And it says right here where it toggles on and off. See where my mouse is. So now it's in radian, and here it's in degree. So let's go back to our paper for a moment for our last problem. We are using some definitions of the angle of depression and the angle of elevation. So the angle of elevation is the angle of which I'm elevating from the ground. So this would be from the ground going up. From ground going up. Okay. Angle of depression is the angle going down. So we have to know when we're describing a situation if we're talking about the angle of elevation or the angle of depression. A traffic helicopter hovering 500 feet above the ground observes a police car on the ground at an angle of depression of 25 degrees. What is the horizontal distance of the helicopter from the police car? Okay, so we want to know this distance here. It looks like it's the hypotenuse. So D is the hypotenuse. That's good to know. And 500 feet is the vertical. I'm just going to redraw the triangle so that we can see without the picture. That's kind of nice. So the helicopter's here. This angle right here is 25 degrees. Using what we know from geometry, that this hypotenuse cuts these two parallel lines. So that angle 25 actually measures this angle here. So this angle is also 25, this angle of elevation, actually. This is a right angle, and so we can find this angle here by subtracting from 90. So that angle is 65 degrees. And we want to know the distance D of between the helicopter and the cop car. Okay, so what things do we know? We know the side opposite 25. So I'm going to use 25 as my as my reference angle. So I'm going to say theta is 25 degrees. And so what I do know is opposite over the hypotenuse is sine. So the sine of 25 degrees is equal to the opposite over the hypotenuse because that's SOH. So and that is equal to 500 over D, what I'm trying to solve. So sine of 25 equals 500 over D. And if I multiply both sides by D, I'll have D times the sine of 25 degrees equals 500. And then to solve for D, I can divide both sides by the sine of 25 degrees, and I can find out that distance. So we're gonna go to our Desmo Scientific Calculator, and I'm gonna make sure I'm in degrees because that's what I have information about, I'm going to take 500 and divide by the sine of 25 degrees. And it says that my distance is 1,183.1 feet is the distance from the helicopter down to the police car. 1,183 is the distance from the helicopter to the police car. So I hope those were some good examples to kind of get you started. Reach out if you have any questions on the homework.